Let's look at this Diophantine equation with prime numbers p, q, r, s in the increasing order. The equation is given as this. We need to find p plus q plus r plus s. By the way, this is from Duke Math Meet back in 2015. Do check out their website and for other interesting problems from the past years. Now here we use simple algebra, rewrite the equation by multiplying PQRS on both sides. We get this. Now notice that the prime number and in the increasing order, that is, when you look at these four terms, S is the biggest, right? So that means QRS is biggest among the four terms. What we get is this important relation here. This four of them is going to be less than 4 QRS because S, R, Q are bigger than P, for example. S is biggest. All right. So with that, this one, pretty much we can ignore that because we're talking about four numbers, and these numbers are from minimum value is going to be 2, 3, 5, 7, the first prime number, the first four prime numbers. So we can just have this equation here. I mean the inequality here, that is P must be less than 4, look at the two ends of the inequality, right? Now P is prime number, and there are two choices, either 2 or 3. Now we need to find out which one is possible by looking at P equals 3. Let's do that. Just plug in the value P equals 3 here. This becomes 2/3, right? And then this becomes 3. Just plug in what we get this, and multiply 3 QRS on both sides. You're gonna get that. Now use similar logic. These three terms here, the biggest is going to be RS. So the whole thing is going to be less than 9RS. Okay, so which means similar argument. Now Q here must be less than 9 divided by 2, which is 4.5, and Q is the prime number, P is 3, Q is the prime number greater than 3. That's not possible with considering that P has to be smaller than Q, right? Q is a prime number, so there's no solution. That means P cannot be 3. We must have P equal 2. When P equal 2, you do similar algebra multiplication by plugging P equal 2, yeah, and then multiply this here on both sides and use a similar argument as before. What I'm going to repeat the argument here. Q is less than 6, which means Q can be either 3 or 5 because Q is a prime number. Okay, now use a similar argument that 5 is not possible. Okay, I'm going to skip the steps here. It's very similar, it's identical steps. We can argue that Q can only be 3. So we have found P and Q. Now we just plug in the value here, right? P and Q. This 1/2, 1/3. The whole thing here becomes 1 minus 5/6, that is 1/6. So plug in the equation here. Of course, P times Q is 6. All right, so use the similar logic, and here R has to be smaller than 12. Now R is a prime number, bigger than 3, less than 12. Two choices. Again, by this time, if 3 numbers are unknown, this is just one unknown. You solve the equation. It turns out that for the 11, you cannot find prime number for that equation, and R has to equal to 7. Okay, when R equals to 7, plug everything in. This becomes just one unknown, one equation. Solve it, and S, of course, equal 43. So that's the answer, PQRS. So the sum here is going to be the sum of these four numbers, which is 55. That's the answer. I think this is an interesting problem. It's kind of unique. We probably not going to find similar Diophantine equations with this sort of a relation. All right, but anyway, please like, share, and subscribe to the channel.